This video will show you briefly how to analyze and visualize current COVID-19 data using Folium, an interactive geospatial library used for plotting data on leaflet maps. So the reason I'm using Folium for this notebook is because it has an option of creating choropleth maps. So essentially binding data to a map for geospatial visualizations. And the task that I've used in this notebook is OpenStreetMap, but you are welcome to use any of the other built-in tilesets or any custom tilesets that you would like to use. The notebook is essentially a tutorial on creating a global choropleth map of the number of confirmed COVID-19 cases for each country. There is also a step-by-step guide to process the data before actually visualizing it. So the first thing I needed to do was to import all the necessary libraries. So the data I accessed through an open source GitHub repository. So if you follow this link, you can have a look at what the repository has, and you can easily clone it into your Noteable home directory using the following code. So once you've done that, have a look at what the folder actually holds. The data we're going to be using today is called the time series COVID-19 confirmed global CSV file. If you have a look inside the CSV file, you can see that there's data available per country, but some of the countries have their data split into states or provinces. So that will prove to be a bit of an issue later on when we actually want to plot it. As the CSV file didn't have any vector data associated with the countries, I obtained this from some raw GitHub data that was available on all the vector polygons of the world countries. So this came as a JSON file, and when I compared the CSV and the JSON files, I came across an issue that some of the countries didn't match in their names. So the data from the CSV file didn't actually bind to the vector geometries of their countries because the country names were different. So first, to actually solve all of these issues that I've talked about before, I had to load in the CSV file into a data frame. And once I had a look at the data frame, I recognized which countries needed to be merged with the country names in the JSON file. So essentially, this whole bit of code is doing just that, matching all the country names so that they all fit. I've also dropped the latitude and longitude columns from the dataset because it wasn't actually needed. Now, the other issue was that there were countries duplicated. So the reason for this was because data was split up into provinces or states instead of just giving an overall summed value for the country. To fix this issue, essentially I just isolated all the countries and summed up the separate regions and then created another row in the dataset with all of those values. So another problem was the issue with Greenland, because Greenland actually had its own polygon on the world map, so it couldn't just be summed up with the rest of Denmark. So I created a row where the country name was Greenland instead of Denmark with the province/state column named Greenland, just to make sure that the data was correctly plotted. I've also replaced all the zero values with NaN because later on I will show you how to plot the data on a logarithmic scale, and since the log of 0 is undefined, that would have thrown an error later on. After I've done all of this, correcting the duplicates, I've dropped all previous duplicated data so that the only rows left of the countries was the actual summed up values. I've also loaded the JSON file into a variable called data so that I can have access to it later on. And I've converted the CSV file into a JSON file, just so that I can add hover tools later on to the third map that I'm going to plot. So first I plotted a linear color map, which also had a widget where you can choose the date that you would like to show. So the problem with this map is that it doesn't look very informative, because the only countries that are even really colored are the US, Brazil, Russia, and India. It is because of their high population. So we're looking at the absolute values of how many confirmed cases there are within a country. So it will be higher in countries with high populations. So a linear color bar is not the right solution. So a way around that was to plot it on a logarithmic scale, and this already made it look much better, much more clear and informative. So now there are some differences that you can see in Europe, Africa, and South America as well. You can also pick the date here if you would like. So instead of looking at the 22nd of July, I can look at the 23rd of July and then see how that changes. But the problem with this map is that we don't know the actual absolute value. So to solve this issue, I added some hover tools to the map. So whenever you hover over a country, it shows you the name of the country and the number of confirmed cases for that day. This way you can have the nice color scale, but you can also have the absolute values of the number of confirmed COVID cases within the country. Thank you for watching, and if you have any questions or if you would like to contribute anything, you can raise an issue on our GitHub repo.